Welcome back, everyone, to another geometry lesson. So if you remember from last week, what we talked about is quadrilaterals, and we talked about the fact that the sum of all the internal angles, the angles on the inside of a quadrilateral, always add to 360 degrees. Now, what I want to show you today is nothing new. There's no new content in here. It's just the manner in which I would go about completing a fully worked problem-solving example. Because I think that communication when it comes to problem-solving is really, really important and something that a lot of people don't do the right way. So I thought I'd show you the way that I do it personally. And that way you can start to practice your own methods of setting out a problem-solving question and communicating your ideas in a concise and cohesive way. So if we look at this question, there's actually not even any words here, but normally at the top what we would have in a problem-solving question is just something like this: find angle A. And that would be all we get. We have to find this angle in here. So the first thing that I would do when I was attacking this question, would be to find out all the internal angles of my quadrilateral. You can see I have a quadrilateral here, 1, 2, 3, 4 sides. Here's my quadrilateral, sort of this arrow shape. And I know this angle is 20 degrees. It's already been given to me. And I also know that this angle is 25 degrees. The two angles that I don't know are this one here and this big one here. So we need to find them. We'll call this, by the way, angle B, and we'll call this angle C, just so we can label them. Now, the first angle that we can find is angle B. So what I could do is I could say angle B plus 155 degrees equals 360 degrees. Now, I know that to be true because we know that a circle is the same as an angle of 360 degrees. And you can see that angle B plus plus this angle that's 155 degrees add up to a circle. So they add up to 360 degrees. So to find B, I just have to take this 155 and put it on the opposite side. So angle B equals 360 degrees. Now when I take over that 155 to the other side, I have to change its symbol. So instead of being a plus, it's going to reverse and become a minus. So angle B equals 360 degrees minus 155 degrees. And when I do that maths, I find out that 360 minus 155 is 205 degrees. So angle B equals 205 degrees. So now I know that this one in here is 205. The next one I need to find is C, which is this one over in the corner. Now, we already know that the internal angles of a quadrilateral add up to 360. So we know that angle B plus 25 degrees plus 20 degrees plus C. Ooh, see, I'm not going to quite manage to keep my equal signs straight, but I'll try my best. Angle C equals 360 degrees. We also know that B equals 205, so we can substitute that in. We can get rid of that B and we can put in 205 plus 25 plus 20 plus angle C equals 360. So now, just like I did up here, I can work out C by taking all of this across and putting it on that side. Instead of doing it one by one, though, we might as well add them up on this side first. So 205 plus 25 plus 20. And when I do that, I could do more on what I did up here when I moved that 155 over to the other side and changed the sign from a plus to a minus. I'm just going to talk a little bit about it down here before I do it. Because really what I'm saying here is that 250 plus a number, I don't know what that number is yet, but I know that it's going to equal C, equals 360. So the question I really have to ask is, what number do I have to add to 250 to get to 360? And when I realize that, it becomes a little simpler to realize why this number has to go over to the other side. Because if I go 360 minus 250, I'll find out whatever's left over after I take away that 250. And that's what C is going to be. Because it's going to be the number that when I add it back onto the 250, I'm going to get back to 360. So I have to subtract it. So angle C is going to equal 360 degrees minus 250 degrees. And again, I could do the subtraction down here or something, but I'm just going to tell you right now that that's going to equal 110 degrees. So now I know C and I know B is 205. I actually don't need B anymore. That was like an intermediate step to get to C. Because we can now see that angle C plus angle A equal 180. So now that I know that, I can work out A, because angle C plus angle A equal 180 degrees. How do I know that they're 180? Because a straight line is the same as a 180 degree angle. Put my little symbol over here to make that clear. There's my symbol. And I could do the same up here, by the way. I could say that this one here, here's a new symbol for you, is true because, like a lollipop, the angles inside a circle add up to 360 degrees. And down here, I could put my symbol for a quadrilateral to say that the angles inside a quadrilateral add up to 360 degrees. So that was a bit of a jump backwards there. So let's jump back down here. What I've said is that angle C, this angle in here, and angle A, this one here, must add up to 180 degrees because they make a straight line. Here's my straight line here. Now I can get rid of this C because I know that C equals 110. So let's do that. 110 plus angle A equals 180 degrees. So now, just like before, when I took this 250 and I took it over to the other side and I made it a minus instead of a plus, I can do the same down here. So angle A, when I take that 110 and I move it over to the other side, is going to become a minus. So it's going to become angle A equals 180 minus 110 degrees, and that's going to equal 70 degrees. And now I've completed my question because I've found what A is. Angle A equals 70 degrees. Now, there's a few different steps there, but you can see every time I've made a logical leap, every time I've done something that requires some prior understanding of the rules that I've used, I've written down the rule. This one is the angles inside a circle add up to 360. Here's the angles inside a quadrilateral add up to 360. And down here is the angles on a straight line add up to 180. So all I've done is go step by step. The same thought process that I used, that I said out loud, I've written it down on the page in order that I thought it, in order that I said it to you. The whole reason we do this is because we need to write our working assuming that the person we're writing it for has absolutely no clue what we did or how we did it. If I just wrote down a big 70, I might get the answer right, but it doesn't tell me how you did it. And that how is really important. Because to be honest, if instead of writing that 70, you wrote a 71, you're only a degree off. But that 1 degree makes the answer wrong. And so I'd mark it wrong if I was marking this as an exam. But if you get 71 degrees down here, and you show me all the steps that you did, all of these steps, And then at this last little bit, you just made one silly subtraction error, and you went 180 minus 110 equals 71 instead of 70. I'm going to look at that and be like, oh yeah, well, this person has clearly followed the right process. They know what they're talking about. They're using all the right rules, and their logic is correct, but they just subtracted incorrectly at one point. And so I'm going to give you part marks there. So you've saved yourself a few marks rather, in your exam. And so this is why we write this working, and this is why we write this logical thought process. Because honestly, I'm more interested as a teacher, and any of your teachers would be the same, I'm more interested in your logic, in your thought process, and your ability to use logic to come to a conclusion that I actually am in the final conclusion. I'm interested to see your thought process, not the final answer. If I just wanted the final answer, I'd just find it myself. What I'm interested is your ability to do it and the logic that you use, the thought process that you use. And that's what you've written down on this page, your thought process. So that's everything for today's lesson. I hope this has been helpful, and I hope you can use this sort of working out these rules and these little symbols to write a cohesive and clear problem-solving response. Because it is a bit of a challenging thing to do at first. But once you get used to it, once you get the idea of what you're really trying to do, it becomes quite easy. So thank you very much. That is the last lesson that I'll be doing on geometry. I might do a couple in the future just on some revision topics for little things that you would have learned in previous years to catch you up. But that's the last lesson that I'll be focusing on for this geometry and parallel lines and shapes and everything. So thank you very much and good luck.